This is section 5.1, part B, trigonometric identities. So in part A, we were starting to deal with our trigonometric identities. We looked at the reciprocal identities, the quotient identities, the Pythagorean identities, the cofunction identities. Now we're just going to be simplifying our trigonometric expressions using some of those properties. The easiest way to do this is to start by rewriting it in terms of one trigonometric function or in terms of just sine and cosine only. So if you can get everything to tangent, you can go that route. If you can't get it all to just one function, try to get them to sines and cosines. So we need to simplify this expression. As you can see, it's not going to be easy to get them all to 1, so we're going to write these in terms of sines and cosines. Remember, cosecant is just 1 over the sine. Secant is 1 over cosine. And cotangent is cosine over sine. So if we rewrite that again, this is just going to be 1 over sine of theta cosine of theta minus cosine of theta over sine of theta. Now to be able to add or subtract fractions, you do need to have the denominators be the same. So the second fraction is going to need a cosine of theta multiplied on top and on bottom of the expression. So this will give us 1 over the sine of theta cosine of theta minus cosine times cosine will give us cosine squared of theta over the sine of theta cosine of theta. Now if we actually do our subtraction, since our denominators are the same, we're going to have 1 minus cosine squared of theta over sine of theta cosine of theta. Now if we think back to what we were doing on part A, we had those Pythagorean identities. One of our identities said the sine squared of theta plus the cosine squared of theta is equal to 1. If we rearrange this expression by subtracting a cosine squared of theta from each side, then we can say that the sine squared of theta is equal to 1 minus cosine squared of theta. So if we go back over to our problem, instead of 1 minus cosine squared of theta, we can replace that because we know 1 minus cosine squared of theta is equal to sine squared of theta. So we can say that this is sine squared of theta over the sine of theta cosine of theta. Now if you notice, we have a sine on top and we have a sine on bottom. This sine will cancel the square. So we're just left with the sine of theta over the cosine of theta. And sine over cosine will just simplify to be tangent. Let's go ahead and simplify this identity. If we look back at our cofunction identities, we know that the sine of pi over 2 minus theta is equal to the cosine of theta. So on this example, we can replace this sine of pi over 2 minus x with the cosine of x. Now if you notice, both pieces have a cosine of x, so we can factor that out. Now that sine squared of x minus 1, whenever you see a squared and a 1, you should think back to your Pythagorean identities. We do know the Pythagorean identity, sine squared of x plus cosine squared of x is equal to 1. If we try to rearrange that so the 1 and the sine are together, we get that the cosine squared of x is equal to 1 minus sine squared. Now if you look at the problem we're at, we don't have it in that correct order, but we just need our signs to be opposite. To do that, we can also factor out a negative 1. So if we factor out a negative 1, that's going to make this a sine squared of x divided by negative 1, gives me a negative sine squared of x. Negative 1 divided by negative 1 gives me a positive 1. Negative 1 times cosine of x we can just write as a negative cosine x. And we can rearrange this, because it's just addition and subtraction, to be 1 minus sine squared of x. Now we know from over here that 1 minus sine squared of x is actually just equal to cosine squared of x. And cosine times cosine squared, cosine to the first times cosine to the second, will give us cosine to the third x. On this example, we have fractions again. The first thing we need to do is to get the denominators the same. So on the fraction on the left, we need to multiply the top and the bottom by the cosine of x. Fraction on the right, we're going to multiply the top and the bottom by 1 minus sine of x. So on the left, we're going to have sine of x. We have cosine times cosine, which is cosine squared of x. And our denominator is going to be cosine of x times 1 minus sine. On the right, we have 1 plus sine of x times 1 minus sine of x, all over cosine of x times 1 minus sine of x. We're going to leave the one on the left this alone here for a second. But on the right, we need to FOIL on the numerator. 1 times 1 is going to give me 1 squared, or 1. 1 times negative sine is minus sine of x. On the inside, we have plus sine of x. And last will be negative sine squared of x. Now if we simplify that, we have a negative sine of x and a positive, so this is going to give me 1 minus sine squared of x. Now, so we don't have to do this work again. If we jump back to that last example, we know that 1 minus sine squared is equal to cosine squared. So we can replace this piece with the cosine squared of x. Now that we have our denominators the same, and we've simplified the numerators as much as we can, let's go ahead and do our subtraction. So this is going to give me sine of x, cosine of x, minus cosine squared of x, all over cosine of x times 1 minus sine of x. Now if you notice in the numerator, both parts have a cosine, so we can factor that out. So that's going to leave us with sine of x minus 1. Sine of x minus cosine of x. Let's fix that. All over cosine of x times 1 minus sine. We have a cosine on top and we have a cosine on bottom, so we can cancel those. Let's back up just a step because I forgot to write that squared when I brought it over to the right side. So I have a cosine squared and a cosine on bottom, so that can cancel with one of those. So we're left with cosine of x over cosine of x times the sine of x minus 1 all over 1 minus the sine of x. If you notice what's in the numerator and the denominator are very similar, just one's positive and one is negative. So if we factor out a negative 1 out of the parentheses on the numerator, sine of x divided by negative 1 gives me negative sine of x, and negative 1 divided by negative 1 gives me a positive 1. So we can rewrite that as negative cosine of x times 1 minus sine of x all over 1 minus sine of x. These 1 minus sine of x will cancel, and that's just going to leave you with negative cosine of x. We want to rewrite this expression so that it no longer has a fraction. When you're dealing with trigonometric functions, you can think of using the conjugate just like you do with imaginary numbers. So right now we have 1 over 1 plus cosine of x. To get rid of that 1 plus in the denominator, we're going to multiply by 1 minus cosine of x because that is the conjugate. So on the top, when we multiply, 1 times 1 minus cosine is just 1 minus cosine of x. On the bottom, we do have two binomials, so we are going to have to FOIL. 1 times 1 gives us 1. Outside is going to give us negative cosine of x. Inside will give us positive cosine of x. And then negative cosine squared of x. When we simplify that, this is just going to give us 1 minus the cosine squared of x. Now if we go back to our Pythagorean identity, we do know that sine squared of x plus cosine squared of x is equal to 1. So if we rearrange this, we know that the sine squared of x is equal to 1 minus the cosine squared. So we can replace that denominator with sine squared. Now our goal is to get rid of fractions completely. So since we have just a subtraction or addition in the numerator and we just have one thing in the denominator, you can actually split those into two fractions. So I can write this as 1 over sine squared of x minus cosine of x over sine squared of x. We know that 1 over sine squared, sine is just the reciprocal of cosecant, so that would just be the cosecant squared of x. Now we can rearrange cosine of x to be 1 times the cosine of x times the sine of x times the sine of x, because sine squared is just sine times sine. So if we rewrite that again, we have cosecant squared of x is equal to, we can split that fraction into two parts again. I can just call this 1 over sine times cosine over sine. Or we can say cosecant squared of x minus 1 over sine is just cosecant, and cosine over sine is cotangent. So now we no longer have any fractions, so we have rewritten this expression not involving fractions.